Algebra 1, number 2.7c. We're going to talk about using the distributive property to collect or combine like terms. And we can combine like terms by using the distributive property of multiplication over addition or over subtraction to factor. If an expression wants us to subtract, we can make an equivalent expression without subtraction. Our equivalent expression will have terms separated by addition signs instead. First, we identify the terms of each expression. In 3a plus 2b plus 4c, these are the terms. There's three of them. 3a is one term, plus 2b is another term, and plus 4c is another term. See? And see how the sign stays with the term? Okay, so if we have negative 8x minus 2y plus 4z, we've got three terms. One term is negative 8x, the next term is minus 2y, and the next term is plus 4z. See? If we want to collect or combine like terms, and they both have the same variable, using the distributive property and factoring, see? We have 2 plus 7 multiplied by m, because they both have the same variable. See? We pull the m out and put it on the outside of the parentheses and put the 2 plus 7 on the inside. See? We get 9m. And if we have 2a plus 3b minus 5a minus 2b, we collect or combine the like terms. We can see the green ones are the same, 2a and minus 5a. So we put those together, and we've got plus 3b and minus 2b. Those are the same, the orange ones. We put those together, and that gets us 2 minus 5a. And it's factored, see? And we get 3 minus 2b, and that's factored. And now we can just do the math. 2 minus 5 is a negative 3. A plus 3 minus 2 is b times b. That would just give us a b, see? Remember our friend, the invisible 1 that sits here? So we don't have to write the 1, we just put the b, right? Okay, what about this one? We've got 3x minus x. Well, remember, our friend the invisible 1 is there, right? So 3x minus x means 3x minus 1x. If you had 3 x's and you took one away, you'd have 2 x's left. That's like 3 minus 1x, so it's factored, and we get 2x, see? Let's try it again with a decimal and a variable. We've got a minus 0.24a. Well, they're both a, so we can put the a on the outside of the parentheses, and our friend the invisible 1 is here, isn't he? So it's like 1a minus 0.24. So we got 1 minus 0.24. Well, 1 whole minus 0.24 is 0.76. A, see? Because we dropped the a down. What if we had m minus 6m? Remember, our friend the invisible 1 is there. So if we had 1 take away 6, that puts us below 0, doesn't it? It drops us down below 0. And if you have 1 and you take away 6, now you have a negative 5m. See? We have the m on the outside, and it's factored. What if we had n plus n plus n plus 4p? Remember, our friend the invisible 1 is in front of every single one of these lone n's, isn't it? So it really means that we've got 1 plus 1 plus 1n plus that 4p. See? So we've got 3n plus 4p. See? How about fractions? If we have 3/4 a plus 1/3 b plus 1/4 a plus 2/3 b, well, we can see the green ones are alike, the 3/4 a and the 1/4 a. We can add those together with the a on the outside of the parentheses, so it's factored. And we can do the same thing with the green ones, with the orange ones, 1/3 b and 2/3 b. 1/3 plus 2/3 with the b on the outside, that's factored. 3/4 plus 1/4 makes 1 a, and 1/3 plus 2/3 makes 1 b, and we know we don't need to write that invisible 1. We don't need to write the 1, right? So we can just put a plus b, see? So just remember, there's a link in the description of this video that talks about the invisible 1, but if you're a regular subscriber, you probably have heard me talk about it before. And we know we don't need to write the 1 because we can just see there's one variable there. It's when we have 2 or more that we have to write that number to know that there's 2 or more, right? Okay, we're going to continue on to our next video, and we're going to go to Unit 2.8. We're done with the distributive property, and we're going to talk about the inverse of a sum and simplifying, okay? I'll see you at 2.8a. Bye.